I know that you know what angular velocity is, but let's go through it anyway. Angular velocity is the number of angles that an object turns through per second. Number of angles in radians object turns through per second. Explain what it is meant in use. State the symbol. The symbol is that omega. Wumbo. You know, I wumbo, you wumbo, ishi, me wumbo. Equals the change in our angular displacement over time. Basic equation. The units here, if the units for angular displacement are radians, and the units for time are seconds, the unit for omega, or the angular velocity, is radians per second. What is the basic equation for angular velocity in terms of period? Well, what the heck is period? Period is the time that it takes, or the time that it would take, for an object to go around a circle exactly one time. So we also know that period is the inverse of frequency, so that's going to come into play over here. Angular velocity, this. If we travel all the way around a circle, we know that we've gone 2 pi r, right? Circumference. So that's the distance we've traveled, and the time that it takes is the period. So angular velocity is nothing more than distance over time. It's just the distance that you would travel around a circle in the amount of time. So the distance you would travel around the circle is going to be 2 pi over the time that it takes to go one complete circle. You'd go this number of radians in this amount of time. 2 pi over t. If we were to do this in terms of frequency, we know that period is the inverse frequency. So if we change this equation to 2 pi over 1 over f, now we're going to do that keep, flip, change, and we get 2 pi times f. All of this is possible because of our bridge equation, and our bridge equation says that if we want omega, we're going to take our translational velocity and bend it over or around a circle.